goes to German, back to English, German, English, German, and at the very bottom, it's completely changed. The problem with communication is the illusions which developed it. So it's not perfect. Actually, there's more ridiculous one that we'll take that up later. Oh, yes.
Can you go back 2 slides?
2 slides.
I would just like to point out that domain, MrFeinberg.com, was our speaker about processing.py a month or 2 ago.
Interesting.
So it's a small world.
That's interesting. He's mentioned in the NLTK book as well.
Yeah.
So it's nothing else.
No, it's no back.
Back to left?
No, back to the repair. I didn't actually see it.
So from beginning to end, it's a total fail. All right, so the human test, the Turing test, is a test that's proposed to kind of see if machines can actually truly simulate human behavior. So basically, can you write a program that completely simulates a human to the point where if you ask the human questions and the program questions, will you be able to differentiate it? All right, so now we're going to look at some key terms. I'm just going to go through this really quickly because this is going to come up later. And some other terms that are going to come up later are based off these very basic terms. So you have classification. Classification is basically writing programs that automatically organize information based on their subject. And in this, you have 2 different types. There's supervised classification and there's unsupervised. So supervised classification is essentially where you feed the program a document. Let's say you give it a document about biology and you say, hey, this is a document about biology. Just look through this, find all the features in here. And then later you give it a document about some other subject and tell it what it is. And then finally you'll give it something that you don't tell it what it is and it's able to detect it. Whereas unsupervised classification is things like clustering and kind of self-developing systems that kind of learn based on the amount of input that's involved. You also have tagging. Tagging is basically attaching a part of speech or some kind of a word sense to words in a document. It's really simple. So basically, if I was to tag a certain paragraph of text, I would basically give every single word that a part of speech or some kind of a sense that it can be anything really. Tokenizing. This is one that you'll see all across the documentation for NLTK. It's the process of breaking text into segments. You can actually, it's basically just breaking it into words. Tokenizing. So you create tokens. Stemming. It's the process of actually breaking a word down to the stem. So things like you take out the tense. So you have for the word jumped. You had jumped, jumping, other senses, and you basically break it down to just the bare word jump, and that's the stem. And there's another term which is, I don't think it's on here, but it's lemmatization, and they seem very similar. Lemmatization is not just breaking it down to the root, but it's also finding something that's related. So, for example, the lemma of evil would be bad. So it's not the root word, but it's something very similar in the same context. Collocations. Collocations are basically when you find a set of words, usually 2 or 3 words, that occur too frequently, that they appear together too frequently for it to be some kind of a coincidence. So essentially you would tell a program to look for these things and say, whenever they see a collocation, you would tell your program that this is something very important. Look at this much further. And n-grams. Basically, they're just different types of tokens. So you have unigrams, bigrams, trigrams. A unigram is tokens of 1. So if I just break up a sentence into tokens of 1 word each, it'd be unigrams. Bigrams are of 2, and trigrams are of 3.
It's like phrases.
Right. Essentially, yeah.
But no, because it can be the end of one phrase and the beginning of another phrase. It's still an n-gram.
That is true. That is true. Yeah. There's overlaps. There can be overlaps. Yeah. So setting up NLTK. There's basically source downloads for Mac, Linux, and there's also installable packages for Windows. The link is right there. You can actually use easy install. You can also use pip. And there's prerequisites. You need numpy and scipy. Okay, so NLTK basically comes with a lot of corpora, and these are texts that you, yes?
Right, what's the corpora?
Oh, yes, corpora are just bodies of text, basically. I mean, it's just text. Large amounts of text. So it's something like, let's see. It's bodies of text that you would use for natural language processing. So things like names, a list of names, popular male names, female names. Things like spam emails, types of emails. And we'll actually look at a lot of data sets. They're basically data sets for the purpose of natural language processing. And essentially what you would do to get all of these is import NLTK and then run this function, nltk.download. And that'll open up, if you're on Windows and you have tkinter installed, it'll actually open up a little GUI that you can just use to kind of browse your way through that. If you don't have that, if you can do nltk.download, you can actually, in quotes, put in which corpus you actually want to download. So, that's the actual GUI that would display if you have tkinter installed. And there's a lot of them. There's a lot. I forget. Ned, do you remember how big like all of them are?
Big.
Really big, right?
Real big.
Yeah, they're large data sets. So be wary about. Because I think the first time I installed this, I actually selected everything and just download, and it took forever. So.
And a lot of them you don't need, like Old English and
Yeah,
Czechoslovakian and stuff like that. So you should pick.
All right, so let's dive into some actual code. Okay, so for the first one, I thought we'd do some part of speech tagging, and the reason, especially the first demos that we're going to go through, really serves the foundation for all the other ones. So you can actually use this in almost any project. These are fairly important ones. For part of speech tagging, these are at the top. You would import from NLTK. You would import POS tag and word tokenize. Word tokenize is the tokenizing function, and part of speech tag is POS tag. Is the part of speech tagger. So on the first one, we have a sentence, and we assign that to a variable. And at the bottom, what we're doing is, when we run it through word tokenize, it'll actually spit out a list. It'll actually spit out a list of tokens. So, okay, so part of speech tags actually have their own kind of syntax. You'll see when you actually give part of speech tags to a bunch of tokens, you'll get a bunch of these abbreviated part of speech tags. And this is kind of what they mean. There's like a whole list of them. This is kind of abbreviated, but they're from the Penn Tree Bank corpus, which you can also download. So this is NLTK text. And this actually allows you to find a lot of the things that, some of the things that we talked about earlier, like collocations from text. And we're actually importing our corpus. So the brown corpus it's a curated data set. What they call a golden corpus, because it's something that is meant for this. It serves as kind of a standard to go against. You're basically guaranteed that everything is syntactically correct in the brown corpus. And so over here, we would import text. From NLTK corpus, we import brown. And essentially, any corpus, you can actually run this on any corpus that you import. If you do brown.words, and there's actually a bunch of categories that are assigned with each corpus, you can store all the text into whatever variable. It'll spit out all the text. And you can store that in whatever variable you'd like. And then what you would do is you would then run that through the text function. Now, that instantiates a text object, and with that object, you can actually run a bunch of these other functions on it that do some kind of interesting things. So you can get collocations, it'll give you word counts, and you can even actually, if you have, this is one of the things you'd have tkinter installed for, is the dispersion plot. And what that does is it actually gives you a pop-up graph that shows the location of each word alongside the frequency. So you can actually see that within this entire corpus, it turns out a certain word is actually really appearing a lot in a certain area.
So what does the collocations function return, or what does it do?
The collocation functions would return a list of tuples of words that are commonly, that it sees that are frequently appearing close together. Yeah. Alright, so this is kind of, this is really interesting actually. WordNet is one of the most useful corpuses, I feel. There's a lot of different things that you can do with it. So over here, we're actually going to take a look at an example where we'll actually be able to take a word and then find other words that are similar to it. And this can, you can imagine this could be useful for something like a search engine. It could be useful for something like creating a tag cloud for a blog post. So what you would do is you would import from the corpus, you would import WordNet and basically run the function synsets on a certain whatever word you want. And that'll actually give you a list of other items. I should probably explain what a synset is. A synset is actually a set of words that are closely related to each other. A synonym set, or a synonym ring, is also known as. With this, with that function, you can actually get that entire synonym ring, and then use that to further get more definitions. And you can even run that function synsets on those synsets, and then get some more. So over here, we're actually taking the word phone, running it through the function synsets, and then we're looping through each one and printing out the definition. And so the bottom list actually shows all the different definitions. All right, so now we're going to look at meronyms and holonyms, and this is something that's fairly confusing because a lot of these words are actually, they sound very similar.
But it is the C.
Meronyms and holonyms are better described in relation to computer science terms as. Meronym terms is kind of like a has-a relationship. Holonym terms are kind of a part of a relationship. And hypernym, think of it as describes a relationship. And we'll actually, we'll take a look at some visual examples so it's a little bit easier to remember. All you really have to know is that meronyms and holonyms are opposites. Hyponyms and hypernyms are opposites, and we'll take a look at that. Burger is a holonym of cheese, tomato, bread, and beef. So basically, if the burger is a holonym of something, it means that it is the larger entity that everything else consists of, that other things consist of. Over here, cheese, beef, tomato, and bread are meronyms of burger. So they are items that fall within a burger. Okay. So if we go back to the previous example that we just did with the definitions, so if we took the word phone and we look for definitions, we could actually modify that. And instead of doing definition, we can actually make it output hypernyms, meronyms, and all that information, all this other information about a certain word. And there's actually this list. I'm actually going to be posting this presentation up on my site, so you can actually go back and then try some of this out. But there's a huge list of different things you can actually get. You can actually get root hypernyms, common hypernyms. So basically words that are related to that. Or so if you give it the word if you give it the word car and you look for meronyms, it'll basically give you things like gear, wheel, engine, things that are within a car.